Okay, these notes accompany our section on rules of exponents. So we should be able to rewrite expressions involving rational exponents using the properties of exponents, which is what we're going to focus on with this. So we have some basic vocabulary. The 5 in this example, we have a power 5 to the second power, or 5 to the exponent of 2, or 5 squared. The 5 is the base, and the exponent or the power is what that base is being raised to. So literally this means the base, it's multiplied times itself, the exponent number of times. So in this case, 5 is going to be multiplied by itself twice. So 5 to the second power represents 5 times 5, which is the same thing as 25. So 5 is the base, and the exponent is 2. And a base with an exponent we call a power. So product of powers rule, a to the m times a to the n is a to the m plus n. Sort of as an example here, we can always do this out the long way. 5 to the second literally means we have 2 5s multiplied together. 5 to the 6th means we have 6 more 5s multiplied together. So we've got 6 5s here, and we've got 2 5s here. And all together, if we're multiplying all these together, we can see that we have a total of 8 5s. There's 6 on 6 here, 2 more makes 8. 6 plus 2 makes 8. So 5 to the 8th is a shorthand way of talking about 5 multiplied by itself 8 times. So notice that if you have the same base, you multiply by adding the exponents. So 5 to the 2 plus 6 is 5 to the 8. So there's a long way to do it. Literally just multiply out or write out what the base with the exponent means, and then just count how many of each base you have. Let's look here at this example. We've got 4 y's, another 3 y's, and another y. So we have to know that if there's no exponent, it's the same thing as a 1. So total we have 4, 5, 6, 7, 8 y's. So y to the 8th is going to be the simplified form there. Let's look at this next one. We've got 7y to the 5th times 6y. Now numbers go with numbers. So we have a 7 times 6 with the numbers. Y to the 5th is the same as 5 y's. And from the other side, we have another extra y. So we end up with 7 times 6 is 42. If we count the y's, we have 1, 2, 3, 4, 5, 6 y's. So 42y to the 6th is the final answer for this one. So numbers go with numbers. That's where the 42 comes from. And 5 y's and 1 more y. 5 plus 1, y to the 5 plus 1 is y to the 6th. So that's where y to the 6th comes from. Let's look at this next one. We have a negative 3 times. Now notice that these, there's no exponents outside the parentheses. We'll get into, that's a different pattern that we'll get into. But what we have here is 2 groups multiplied together. The numbers go together. Negative 3 times 5 makes a negative 15. And then the x's go together. We got 2 x's with another x. That makes 3 x's. And the y's go together. We have 7 y's and another 6 y's. That gives us 13 y's. Y to the 13th. So we get negative 15, x to the 3rd, y to the 13th is our final answer for that one. Now when we divide powers, we subtract the exponents. And we can also do this without knowing the rule by cross-canceling. So y to the sixth in the numerator literally means we have 6 y's in the top of a fraction. The single y in the denominator means we have 1 y in the denominator. We can cross cancel and replace by 1 any common factors between the numerator and denominator. If we count what we're left with, we have 1, 2, 3, 4, we have 5 y's. So y to the fifth is the final answer. The rule says that when we divide exponents, we subtract. When we divide bases with exponents, we subtract the exponents. So y to the sixth divided by y to the first is y to the sixth minus 1. The bottom exponent is subtracted from the top exponent. Gives us y to the fifth. Okay, for the base 6, we've got 6 to the 13, take away 2, gives us 6 to the 11. For this next one, we've got 10 divided by 15. Now 5 goes into 10 twice, and 5 goes into 15 3 times. That's going to basically simplify to 2 over 3. In terms of the a's, we've got 7 take away 5. That gives us a squared. And in terms of the b's, we have 9 over 9. Those are basically going to cancel out and just be 1. So we end up with 2a squared over 3. Now the long way to do that, other than the 2/5, would be to do 7a's over 5a's. And you cross cancel pairs of a's out. You take 5 out of the bottom, you take 5 out of the top, and you're left with 2. And then with the b's, you've got 9b's over 9b's. They all cancel out. We're left with 2a's. There's the a squared. And the 10 over 15, it basically simplifies to 2/3. It would be wrong to do like 0.67 or 0.66 for the number part. Unless you're given decimals, you should stay with fractions. Okay, let's move on. 0 exponent. Anything to the 0 power other than 0 is equal to 1. So let's see what we got here. So how does this work out? If we use our rule of division with a base of 8, we actually have 8 to the 2 minus 2, which gives us 8 to the 0. And we know that 8 squared is 64. So we end up with 64 over 64, 8 squared over 8 squared, which simplifies to 1. So here's a demonstration that something to the 0 power actually has to equal 1. So this negative 3x plus 7 group to the 0 power is 1. 8x to the 0 power. Now here we have to kind of think about order of operations. We really have 8, and x to the 0 is 1, and then we have plus 5. So 8 times 1 plus 5 is 8 plus 5, which is 13. Now, if this was written differently, and it was 8x in parentheses to the 0 power, then that whole thing would end up being equal to 1. But in this case, the x is to the 0 power, and it's 8 times x to the 0 power, so 8 times 1 plus 5. So you got to be careful with those. Negative exponents really means I take it as the number should be written in the other side of the fraction as a positive exponent. So see what we got here. So if we use our rules of exponents for this one, with division, we have b to the 2 minus 5, which gives us b to the minus 3. Now b to the minus 3 literally means you have 3 b's that are in the opposite side of wherever it happens to be written at. So I could throw this over 1, b to the minus 3 over 1. The minus 3 now means this b needs to be in the bottom of the fraction. So we have 1 over b to the 3rd. So this negative exponent needs to move to the bottom and become a positive exponent. Let's see what we have here. So we generally want to always write our work with positive exponents. So here we have 2 to the minus 3 power. Now 2 to the minus 3 could be thought of as 2 to the minus 3 over 1. We can always put anything over 1. But this means we have 3 2's, but they're written in the numerator, and they should be written in the denominator where the exponent would be positive. So the negative in this case kind of means it's in the wrong place. So this is better written as 1 over 2 to the positive 3. Here we have negative 3 to the negative 3 power. So negative 3 to the negative 3. This whole base is to the negative 3 power. Again, pretend it's over 1. And the negative 3 really means that this base, which is negative 3, needs to be rewritten in the bottom of the fraction as a positive. Let's move on. Power of a power. Literally, you have n sets of MAs, if you want to look at it that way. And so we deal with this as a shortcut by multiplying the exponents together. So if you have a pattern where the exponents are close together, that's a clue that they're going to be multiplied. So x to the 2 times 8, or x to the 2 to the 8th, literally means you have 8 sets of 2x's. 1 set, 2 sets, 3 sets, 4 sets, 5 sets, 6 sets, 7 sets, 8 sets. 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 sets of x squareds. Altogether, we have 16 x's. So x to the 16th is going to be the answer here. And the shortcut for that is to take the base and multiply the exponents together. We call that the power of a power rule. And 2 times 8 is 16. So that's the shortcut to get x to the 16th. The exponents are written close together, you're going to multiply them. Okay, here we have y to the minus 3 to the minus 4. Minus 3 times minus 4 is a positive 12. Y to the 12th is going to be the answer for that. Power of a product. There's like a distributive property that goes on here. This m goes with the a, and the m also goes with the b. So this is a to the m times b to the m. And we can write it as a to the m, b to the m like that. And you find the power of each factor in the parentheses and multiply it together. So we have 4 to the 3rd. We have x to the 3rd to the 3rd. We have y to the 1st to the 3rd. And we have z to the 1st to the 3rd. So all I really did here was take this exponent of 3 and distribute over everything inside the parentheses. 4 times 4 is 16 times 4 makes 64. We've got x to the 9th. 3 sets of 3 x's is x to the 9. We have 3 sets of 1 y, that's y to the 3rd. And we have 3 sets of 1 z, z to the 3rd. So there's the final answer for that. Here we have one with a negative exponent. So we're going to use our same rule, but then at the end, to get rid of the negative exponent, we're going to move it to the opposite side of the fraction. So we have 7 to the minus 2 power. We have x to the minus 2 power. We have y to the minus 2 to the minus 2 power. So this minus 2 power has been distributed over everything inside the parentheses. 7 to the minus 2. 7 squared is 49. To the minus 2 means it's in the bottom. We have 1 over 49. X to the minus 2 means we have 2 x's that should be in the denominator. So we have 1 over x squared out of that one. And y to the minus 2 actually gives us y to the 4th. So when we multiply all of these together, we have basically y to the 4th in the numerator over 49x squared as our final answer. So I kind of did the negative, turned it into a power exponent as I went along. This was the answer for the other one. Let's look at this one. This is to the negative 2 power. So we've got 6 to the minus 2. We have x to the minus 6 to the minus 2. We have y to the minus 7 to the minus 2. and we have z to the 0 to the minus 2. See what we get out of that? 6 to the minus 2 is 1 over 36. X to the minus 6 to the minus 2, minus 6 times minus 2 is x to the 12th. Y to the minus 7 to the minus 2, minus 2 times minus 7 is 14. It's positive, so it stays in the numerator. So we get that. And z to the 0 to the minus 2, 0 to the minus 2 is 0. So we have z to the 0, which is the same thing as 1. So what you end up here is x squared, or x to the 12th, y to the 14th over 36 as our final answer. Let's move on. Power of a quotient. This exponent gets distributed over everything in the fraction, and then we can simplify from there. So literally this means 3 squared over 5 squared, which gives us 9 over 25. Next one, 2 squared is 4. A to the 5th to the 4th, or a to the 5th squared. And then here we have b to the 7th squared. Simplifying, we've got the 4. A to the 5 to the 2 is a to the 10. And in the denominator, we have b to the 7 to the 2, which is b to the 14. That's how those would simplify. Over here, these are to the third power. 3 to the third power is 27. A to the minus 4 to the 3 is a to the minus 4 times 3. That's a to the minus 12. And in the denominator, we have b to the 7th to the 3, which is b to the 21. Now, there we have an answer. If we need our answer in positive exponents, this a needs to move because of the negative exponent to the bottom. So we have 27 in the numerator. The a to the minus 12 moves to the bottom and becomes a to the positive 12. And then we have b to the 21st. Looking at the next one, a to the minus 2 to the minus 6 is a to the 12th. B to the minus 5 to the minus 6 is b to the 30. And c to the minus 11 to the minus 6 is c to the 66th. And that's it for that one. Okay, so those are our notes for rules of exponents.